looking at this making stuff channel with the xTool Laser Welder, and I watched the video and something was off. I had a gut feeling that something does not look right. And going through the videos and taking some stills, about halfway through, I said, hey, maybe it's possible. Until later in his second video, he showed some angles that are a smoking gun to me, and I'd like to show you why I feel that way. And I mean, no mercy for scammer liars. There must be no mercy. And if I am incorrect, if I don't understand materials and technology, then I am the dirtbag, and I suck. So please call me out if I'm mistaken, and help me learn about this new technology, because I need to learn. I need to update my databases, my brain, with this new information. But as it stands in my understanding, this looks completely fake. So here's my hypothesis. My hypothesis is that after the part was, quote, stomped, it was re-welded. And so let's go through this and look at some evidence here. So here's that first weld, and you can see a scratch here, and on this view, here's that one scratch there, telltale scratch. To figure out what side that's not the conspiracy. Scratches are not the conspiracy. So if we look at the second weld, we could see some contamination here build up. Doesn't have those scratches. And here's that, I don't know, the rust transfer or whatever that was, and the black line here. So we're just trying to identify the sides. And then here's that stop. You could see the that contamination on the edge here. So we know that second weld is on the inside. See that contamination? I'm down with that. And then got a little gap here. See that gap? That corresponds to that gap here. Okay, we're good there. Now we get into some of his close-ups. I think, yeah, so since this is a much clearer, this is that second video. So we're looking at the aftermath. I want you to take note. Well, we got our scratch here. We got this scratch. We got that scratch. The slag here and these beads on the surface, it's hard to get a reference to line those up to one, and I'm already investing time into this. You'll see why I'm not even going to go that far. So we're looking at this, and one thing you'll note is this kind of a bulge here, and these laser welds are so consistent. It's not like we can count these lines here and compare them before and after. And then let's look at another angle. So this is where I started being very suspicious of what is going on here. And then, like I said, when I was initially looking, I mean, I do see this. So the aluminum is going to lose its temper and it's going to get soft. And that's actually tricked to bend 1/8 inch or thinner aluminum to bend it. What I do is I take a TIG torch, no filler, and I just bead across the bend line. And then you can bend it without it fracturing. Okay, I get that. I'm on board with that being the possibility. It still looks weird as far as the plastic deformation. It still looks weird. So let's continue. And here's that before and after. And now again, look at that. What is that? Why does this look wider? And that looks pretty straight across there. And it's getting difficult with the camera angle. There is suspicion. I'm not very confident, but that distance from the beginning of the weld to there, let's give you some color. So that distance, it's hard to tell. Again, it's hard to reference that. So it's suspicious, but I don't think we can make hard conclusions with that one. So now we look again at that bulge. So here I took this red line and I put it at the corner of the material and kind of brought it across. And over here, corner of the material, brought it across. And you do see that bulge here. So what's interesting is how this material, like this edge here, moved and the weld stayed in the same spot. So this red line is sort of representing the edge moved through the backside of the weld and up, which is pretty odd. So that's, again, not a hard evidence, but it is suspicious. So now we're getting towards the disaster here. So this is a good view to see the orientation of this material and how it bent. And we can only assume that it's bending around a point. That the material bends around, say, this point. Maybe we could zoom in here. Bends around this corner. And let's see if do I have a free draw tool. Okay. So that's my understanding of that. So how that edge moved. So the edge started here, it pivoted around here, started here, and then this edge moved up. So that's where I'm having trouble understanding what's going on here. With the weld bead or the material around it should reflect this distance that it bent over. So let's start looking at this. And he starts showing some angles, so we're progressively going to see some different angles here. As he rotates the camera view, look at this. So here's that corner. What is up with that? That looks odd. Why does it appear that way? So let's take a reference on this corner. So if we go back to this image, that corner is sitting down on the material and the bead is basically over that corner, 50%. So then how did that edge flow through the weld bead? That's the confusion here. What kind of material is this? Play-Doh or a rubber cement and then sprayed with I'm just making stuff up, but that's the struggle in my mind right now of what is going on here. Why does this look so weird to have that like that? How did that filler material flow so perfectly? So this is another great view. Let's get the pen. So we're assuming it's pivoting. So that is an assumption on my part. We're pivoting about that point. So this corner started right here. Here, let's make that less exaggerated. So that width there, hey, lesson in PowerPoint. We go like that. Oh my gosh, sorry. There we go. No, don't fill. So that corner started here and moved up. Come on. Why am I incorrect here? why does this appear to have been re-welded? Or when it was stopped, okay, another hypothesis then to make this real, to explain this, is this corner here shifted as he stopped it. So this corner in the material started here, and then when he stopped it, the corner of that material shifted over. Or maybe this was a better view. So that the what I'm getting at, so put another reference. So look at this edge here. Make it bigger and brighter for you. The edge of the weld here is the edge of the weld here, right? Okay, so do you see the distance? If I bring this all the way out, we have the edge of the material, the corner out here, and the edge of the bead there. So if we jump back to here, this red edge is now over the top of the green reference line. How is that possible? Is there another view? Yeah, we're getting even more. So how is this, that red edge, let's bring our reference lines over. We got our green one. So this is now directly over the top of this edge. So then that means if this is real, if I am incorrect and I am the a-hole here, then possibly this is what happened, which is blowing my mind. So this corner of the material right here, that corner, right there, that corner moved this way in order to get this edge above this green line. Where it started out here, that edge is behind the weld, and then there's a distance between these two. So if it pivoted about this point, then that edge would not be over top of this. So let's jump into CAD and play with that. Okay, I got started in CAD, built these two components. These are 1/8 inch thick. So let's go ahead and make a reference sketch here. Activate this guy. Projection, break link. Okay. So how wide was that? Like, I'm trying to find the edge of the bead. In the presentation, I had that line, this green line. So I'm trying to determine this green line, like from here. So let's make a reference of that green line. So let's say we'll go, it's a small, let's say 2 millimeters out. I mean, that's given the benefit of the doubt there. Make a construction line. So that's just reference geometry. Okay, I'm investing way too much time into this. Okay, so we got the edge, that green line here, reference, green line there, and we can obviously, since we're in CAD, we see the edge. So let's go ahead and stop this part, virtually stop it. We'll do a rotate, select the axis, and here we go. Stop the part. Boom. Okay, we stopped it down, maybe that angle. Okay, so you see quite a bit of distance from that edge of the original weld in the corner here. So that's assuming it's bending about this corner to get that type of angle. And let's go back to our PowerPoint and look at that again. So how is that edge? Why is this edge here right above that? That looks real shady. That looks messed up. So again, please understand that is why I'm questioning this. So this is throwing me off, so I'm just trying to understand what is happening here. Why is this corner edge here? So we're assuming it pivots around there. So okay, so then it did not pivot around there. If this is true and I am incorrect, I'm the bad person. Oh, look at that warp. Look at that piece warped there. Interesting. Because the claim was it doesn't warp the part. Okay, so it doesn't do that. Let's cancel that. How are we going to do this? We can rotate it about the middle maybe and lift it. Yeah. Let's try and do that. So I need to make some more reference line again. Oops. We'll do a reference line in the middle. Alright. And now let's rotate this part. We want to rotate about this axis. So if we do rotate about that axis, we're going to have to do another thing. So now in your mind's eye, that weld bead is stretching, right? It has to. Go here. I have to freehand this one. Might be easier to move this part. Okay, so that doesn't really add up. So this part had to lift up while it's bending. So, I mean, I guess that's it. Here's my case that this is a fake scam. I am prepared to learn from my mistakes and be publicly shamed if I'm incorrect.